Hey physics students, this is Miss Bala and I'm here to just give you a bit of understanding about the fundamental concepts of the egg drop project. So to begin with, let's just talk about what this term drop means. So egg drop, the term drop means that you're releasing the structure with the egg from rest. You're not throwing it, you're not giving it an initial velocity, you're just releasing it from rest. So the starting velocity is going to be 0 meters per second. Okay. Now here I have two sample structures, just two models, and we're just going to talk about these models. So as they start falling, when you drop them and as they start falling, can you tell me what is the difference between the forces acting on structure 1 and structure 2? Take a second to think about it yourself. So notice this one has a parachute, this one does not. So if you were to draw the free body diagram, what force would you represent for the structure 1? Let's label this 1 and 2. So for the first structure, the only force acting on it is, if you have guessed it right, it is the force of gravity. For structure 2, what else do you think is the other force that is acting on it? I know that you said that right. That would be the air resistance. So there is the force of gravity, and then there is air resistance. And you know that the force of gravity can always be calculated as mass times 9.8, which is the acceleration due to gravity. Okay. And force is always expressed in newtons. So now this one is only one force acting downward. This one has a force acting downward and a force acting upward. So how do we find the net force in structure 2? That is correct. Because these two vectors are in opposite directions, the net force is going to be the difference between the two forces. Therefore, which one will have a smaller net force? Again, if you set structure 2, you're right, because the net force here is the difference. This will have a smaller net force. So here the net force is smaller. Here the net force is bigger. And to find the acceleration, you would take the net force and divide it by the mass. So we have not talked about the mass of these two structures. And by looking at it, I can estimate and say that the second structure has probably a smaller mass, while the first structure is slightly heavier. So you take the net force and divide it by the mass, and that will give you the acceleration. So it is very likely that structure 2 has a smaller acceleration because of the fact that the net force is much smaller. And if the difference in mass is not too much, then this is likely to have a smaller acceleration. But with numbers, you can actually compute it. So using a parachute reduces the net force and therefore reduces the acceleration. So what is the effect of having a smaller acceleration? By the time these two structures hit the ground, which one do you think will have a higher velocity? Yes, structure 1 has a higher acceleration, so it will have a higher velocity, whereas structure 2 has a smaller acceleration, so it will have a smaller velocity. Now the question is, which of these two structures will save the egg? So for that, we have to talk about the force of impact. So not the force during the fall, but remember, this is the force that is the force exerted by the ground on impact, which makes the egg and the structure stop, right? So we want to talk about the impact force that happens on the ground. So the formula for force is, you can either write m times a, or you can, from this unit, you can use the formula change in momentum, otherwise also known as impulse, right? So force is impulse divided by time, and if I expand impulse, impulse is change in momentum, so it is going to be final momentum minus initial momentum. The symbol for momentum is P. Again, expanding this even further, you can write momentum is mass times velocity. So it is mass times final velocity minus mass times initial velocity divided by time. So the force is going to be determined by this expression. Now the final momentum, when the egg and the structure hit the ground, finally they are going to come to rest, right? It stops at the end. So the final momentum is going to be 0. So you can just cancel this out. So that means the force is going to depend on this momentum with which it strikes the ground and then the time taken to stop. Remember, this represents the momentum with which it hits the ground, and this represents the time it takes to stop. So naturally, if this momentum is smaller, the force will also be smaller. That means if you have a lighter structure or the speed with which it hits the ground is smaller, either of them is small, that means that will make the impact force less, and therefore your egg can be saved. Another thing to consider is the stopping time. If it takes a longer time to stop, that means if this time is more, because it's in the denominator, that means your force will be less as well. So that means in your structure, even if your structure stops quickly, you must design a structure such that the time for the egg to stop should be a lot more. As in, if we look at structure 1, let us say that this structure, all of this is some kind of a sponge or foam type material. So even though the whole structure will hit the ground and stop quickly, the egg inside will slowly sink and take a longer time to stop. So any type of foam padding or cushion for the egg will prolong the stopping time, and a longer time will automatically mean a lesser force. Okay? So the ways by which the egg can be saved is going to be determined by how light the structure is, and then what speed with which it strikes the ground. Does it hit the ground with a smaller speed or a bigger speed? And then how much time does it take to stop? Other than these, there are also other things to consider. Does the force spread out over a wider area? Is the base very stable? Will the egg topple or be bouncing back from the structure? Other things also to consider. But using the impulse momentum equation, which is this one, this is how you will discuss how to reduce the impact force. I hope this discussion was useful in answering questions about the project as well as the DBA questions. And I haven't talked about terminal velocity, but I do have resources on the class notebook for terminal velocity, so do give it a look. Okay, we'll talk to you on your DBA.